So the next thing that we're going to talk about are planes. Now, if I can draw one here, and let's see, I think there's a way, if I remember right, to, how do they do that? It's not rotate, is it reflect? Uh, it's going to be, I didn't put it up on YouTube, but it will be up. Hopefully tonight I should do that. Yeah, 1.B, yeah, page 3. And you didn't get a book, too. Yeah, grab a green one up there. Shear, is it the shear thing? Yeah, that's probably what it is. So let's go like 30 degrees, see what that looks like. Yeah, that's what I want. Cool. I should have had that already pre-made, but I've had the whole summer off using this program, so I forget where a lot of things are, so I gotta remember. So this is basically a general picture of what we consider to be a plane. Now we talked about a point. A point is just a place in space, okay? And we talked about how to label a point. I think we did, didn't we? Yeah, capital letter for a point. A line, we said 2 letters, or you could use a lowercase letter, depending. A plane is basically just a whole collection. It's a collection of lines is basically what it is. Now it looks like it has an edge to it, doesn't it? But it doesn't just stop. A line keeps on going, so a plane keeps on going. For instance, the ceiling could be representative of a plane. Now the ceiling stops, but the plane that the ceiling is in keeps on going forever. You follow me? It's like a flat, basically it's kind of like a flat surface. It just keeps on going forever and ever in all these directions. All right, so we label a plane by using a capital letter. You can put it in any of the corners. Doesn't make any difference. They call this plane, oops, I'm going to have to change something real quick here. There we go. And we could call this like plane P. All right, I could have put it down here at the bottom. It doesn't matter. Just you stick it in some corner. It's just a capital letter. All right, so we call that plane P. There's no fancy symbol for plane, so you would just write plane P. All right, so you'd actually write the word out. My writing's, I've got to get used to using this thing again. But that's how you would say this thing. Now, I don't know if they say it in here. I don't think they say it in here, but you could do this. Watch, if I had a point here, one here, and one here. We'll call this A, B, and C. Now you could call this plane ABC. You could take any 3 points that lie on the plane itself and then call it that. It doesn't look like this book does that very often. I just taught a lesson today in my geometry class, and the book in that class actually uses that as an example. You could use 3 points that lie on the plane. Now P is not a point. It's just the name of the plane, okay? These are all points, A, B, and C. I couldn't name it plane A or plane B or plane C, but I could call it plane ABC, right? So I could say plane, and then you just put the A, B, and C next to it. So those are different ways that you could call it if you wanted to. All right, let's get through that. Now, in order to have a plane, you must have 3 non-collinear points. Did we talk about collinear yesterday? Yeah, collinear means what do the points do? They all lie on the same line. Good. All right, but if you have 3 non-collinear points, that means you can make a plane out of that. For instance, let's say I had, look up here, if I had a point right here, and right here, how many planes could go through those 3 points? They lie on the same line. Okay, here's one like this, but what about the plane going through here? What about the plane going through like this? What about like this? How many planes could you have that go through the 3 collinear points? 6? Just 6? One here. How many different angles could I go? An infinite number. That's right. You could go an infinite number of planes, couldn't you? Right? I mean, I don't have a sheet of paper here, but I mean, I could have a piece of paper going this way through these 3 points, right? I could have it going this way. I could have it going this way, this way. How many times could I do that? As many times as I wanted to. Okay, an infinite number of times. You follow me? That's collinear. But what if they're non-collinear? What if I had a point here, and a point out here? How many planes could sit? How many planes could contain those 3 points right there? Just one plane. Do you see it? So if I took a flat sheet of paper and I set it right here, that's the only plane that could contain all 3 of those points. Would you agree? I mean, if I tilt it up, then it doesn't include all 3 points because that point's sitting over here, isn't it? You follow me? So 3 non-collinear points right here form a plane, basically. Okay, that's the least number of points. Are you okay with that? All right, enough of that. Let's just go through some things. We could talk about a, now I gotta remember I used to remember what my shortcut was for this. What is it? Oh, it's that thing. Okay, so watch. I could have a line like this. I say this line is on the plane, or you could say in the plane, or you could say the plane contains the line. You could say all kinds of things. I'll probably just say it's on the plane. So line, we'll call it line L. So line L lies on, what do you think? What does it lie on?
It lies on a plane.
On which plane? Be specific.
On the ABC plane.
Okay, you could say plane ABC, or you could say plane P, right? Either way. All right, so line L lies on plane P, or it lines on plane ABC. You with me? All right. This is all like just vocab, just so we're on the same page and we're speaking the same language here when we talk about these things, okay? What if you had something that looks like this? I'll try my best to draw this. What if you had a line going like that, okay, and it hits, and then I'm going to try to make this, and it goes like that. Yeah, I guess that's good. Alright, so and you got arrows both here, and it hits right there. We'll call this point M. What about this line? We'll call this line R. Would we say that that line is on the plane? What's it doing? It's going through it, right. Okay, it's like you had a sheet of paper, right? And you had, let's say, this pen right here, right? And it's going through the plane, okay? It's intersecting the plane. Where does it intersect the plane? At where? Be specific.
M.
At not just M, at point M, right, okay? Just trying to make sure we say everything correct. So we would say line R intersects what? Plane P at point M. You got it? Okay, so that's how we would say it so that people would completely understand what we're talking about.
Can that be line M?
No, it wouldn't be line M because this is a capital letter and it represents just that one point. Now, if I did this, if I put a point right there and called it N, I could call it line NM or line MN.
So you would have to have two.
You would have to have 2 points to use the points, right? Like right here, I don't know any points that lie on that line, so the only thing I could call it would be line L, right? If I just knew one point on here and I called that D, I couldn't call it by the points. I couldn't call it line D, all right? I could only call it line L unless I had another point that I knew. Let's call it, oops, E, all right? So now I could call this line L, I could call it line DE, or I could call it line ED. Got it? Okay. All right, enough about that, I think. Oh, what if I had, we talked about collinear means what? 2 points that do what? On the same line. What if I had this? What if I had 2 lines and they lie where? On the same plane. What would I call this line L and this line, I don't know, I'm running out of letters, S? What would I call that? Coplanar, that's right. 2 lines that lie on the same plane are coplanar. C-O-P-L-A-N-A-R. Okay, coplanar. Coplanar. All right, so 2 lines that lie on the same plane are coplanar. 2 points that lie on the same line are collinear. Again, this is just all vocab stuff. What if I had a line out here like this? I know I'm going into that stuff, but what if I had a line out here? Could I say that it's on the plane? Should I say it intersects the plane, goes through the plane? Well, we're not really sure. If it was perpendicular, it would probably go through the plane then, wouldn't it? But we just say it's
parallel.
You could say, I guess you could say it's parallel. Let's say, actually, what they say, yeah, I guess you could say parallel, but we just say that it's not on the plane. Okay, it just doesn't lie on the plane. All right, which would represent what? It's like if you had a flat surface. We use this top right here as a flat surface. Here's the plane right here. Where would that line be? It wouldn't be here. That would be on the plane. Where would the line be? It'd be up like this. Okay, it wouldn't be tilted, so it goes through it. It'd be like this. You could say parallel. That'd be fine. You said that earlier, right? Yeah, you can say parallel to the plane. All right. Enough of that. All right, that's enough of planes. You tired of that yet? I am. Let's go to the next one, which is angle. All right, now we're going to talk about angles. So watch this. I'll draw an angle here. I'll just draw it like this, and then draw one about like that. That's good enough. Put arrows on the ends of it. All right, these two things right here, it's got one arrow, but then it ends right here. So what would this thing going off at this one that I'm sketching over right here, what would that be? That would be just by itself. What would that be considered? Well, we talked about this yesterday. You weren't here yesterday, but it's not a full line, is it? Because you don't have arrows in, going this way. It's a ray, yeah, because it's got an end point and it keeps on going in the other direction. Everybody see that? So that would be a ray. So how many rays do I have here? I have two rays. I've got this one and I've got this one here. Okay, they're two different rays. Now they share the same endpoint though, don't they? That endpoint that they share, do you remember what that thing's called? Vertex. Good. It's a good geometry word, right? So that's a vertex. So the endpoint that the two rays share is a vertex. So anytime you have two rays that share the same endpoint, now you can look at the whole entire thing, not just them individually. So two rays that share the same endpoint are called a what? Or an angle. All right, so this is an angle. All right, easy enough. Now, how do we measure angles? I don't care about this too much, but in the book you'll see they talk about this being the initial side and this one right here being the terminal side. You start with the initial side where you're starting, and this is how we usually measure the angles. We'll talk quite a bit about this as we go on further in the book. But this is how we would measure it. Let's say we measured it and it was 30 degrees. All right, there's another way to measure an angle. Not just go in this direction. This would be what? Counterclockwise. You could measure it. How else? The other direction, or what? Clockwise, right? All right, like that. Now, how many degrees would that be? That big old angle thing that I just drew right there.
330.
That would be 330 degrees, right? Okay. You with me on that? So there's two ways. It's actually negative because we're going in the opposite direction. We'll get more specific with that as we get closer to it. But this would be negative 330 degrees because we're going in the other direction. When you go clockwise, that's actually the opposite direction when we talk about angles. And when we go counterclockwise, that's actually the direction we want to go. All right, seems kind of different from a clock, but that's that. We good with that? That's an angle. Now, how do we name an angle? Let's get rid of some of this stuff. Boom, 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 boom. Get rid of all that. And I just want to, yeah, there you go. I just want a nice clean angle now. How do we label this? Well, array, how many points do you need to label array? Two. For array, you need 2 points. So we'll just call this A, we'll call this B, and we'll call this C. So if I was going to name this angle right here, you could name it two ways, actually 3 different ways. You could name it with just the vertex. All right. So what is the point of the vertex? It's A. So you could call it angle A, and it has a little symbol. You've seen this before, right? It's not a great. That looks a little bit better. Okay, angle A. You could call it angle A, or you could call it angle what? BAC, that's right, because what has to be true about the vertex? It has to be where? It has to be in the middle, that's right. So you can go any direction. You can go BAC or what else? CAB, good. So it's, you could go BAC or you could go angle CAB, doesn't matter. All right, so any of those are valid ways to name that angle. You got it? All right, what if you had a situation like this? What if you had one going like that, one going like that, and then one going like that? Put the ends on here. And what if you had A, B, C, and we'll call this one D. All right. Now, if I wanted to name this whole big angle right here, do you see? I put an arc right there. If I wanted to name that whole big angle right there, what would I call that? Yeah, you would have to call it ADC. This time you couldn't just call it angle D. Why not? Yeah, there's a line going through here, but how do I know what angle? If I just said angle D, that doesn't tell me much. I don't know if I'm talking about this angle right in here or this one right here or the whole big one, right? So if you have more than one angle coming out of that vertex, I have to use the 3 letters. I can't just use one. Right here, that was the only angle. I couldn't be talking about any other angle, could I? So that's the only one I can talk about. I'm running out of time on my YouTube thing, so I have to stop this and then we'll resume in a second.